Hey guys, in this lesson we're looking at non-linear systems of equations. We've looked at linear equations, linear inequalities, all that sort of stuff. Now we're looking at non-linear, which just means one of them, at least one of them, is not a line. It's possible they're both not lines. So think about things that we know that are not lines. We could have a parabola and a line. We could have a parabola and another parabola. There's lots of things like that. What we will be looking at parabolas, obviously, because those are not linear. We'll even be looking at some other ones that we'll dig more into when we get to chapter 8. Circles, ellipses, hyperbolas. Those are all different non-linear equations that we're going to be looking at in these types of systems. So for now, you don't have to worry about what they look like. We're just going to be doing the algebra and going from there. We can do substitution or elimination, just like we did with linear systems. You can use either one. Substitution or elimination. So this first one, we're going to look at doing a substitution, because these are pretty easy to just solve for y. So if we got y by itself, we'd move it to the right, we'd move the -2 to the left. We have 3x plus 2, and then it's just a straight substitution. You plug in 3x plus 2 in place of the y. And now solve. So since we plugged it in, we used parentheses like we should have. We have to distribute that negative. And to solve this, we can factor. If factoring doesn't work, you would use quadratic formula. Hopefully most of the time on these, factoring will work. This will need to factor to be, we'll work it out with steps rather than just jumping straight to it. We can split the middle term using that trick where we multiply 4 or 2 times the -2 in the back to get -4. And now we need two numbers that multiply to be -4 and add to be -3. That would be -4 and +1. So we're splitting our middle term as our factoring trick here. We'll keep the -2, we keep the 2x squared here. And now that we split the middle term, now we have 4 terms, we can split this into factor by grouping. There's no common factor here to factor out. You can put a 1. And now our parentheses match, which is our requirement for factoring by grouping. We get 2x plus 1. The front factored out terms, and then the x minus 2, the parentheses that match. So that is now factored. And now since we are solving this, we need to solve each piece. X equals +2, 2x equals -1 when we move each of those numbers over, move the constants over. So x equals -1/2 and x equals 2. So for these, since it's a system, it means we need x and y. We have 2 different x's. We need the y that goes with each of those. So let's take our x equals 2. And we're going to plug it in right here. We get y equals 3 times 2 is 6, plus 2 is 8. So that means our ordered pair solution is 2, 8. And then our other solution we had for x was x equals -1/2. We plug that in as well. So we get y equals 3 times -1/2 will be -3/2 plus 2. negative 3/2, that's negative 1 and 1/2, plus 2 is just 1/2. If you needed a calculator, I guess that would be okay. It wasn't really a hard question though. So we got our two solutions, two ordered pairs, because when you think about what these were, and I drew it out on the previous slide, we have a line and a parabola. It makes sense that they could cross twice. It's also possible you get no solution, they miss each other. Or it could also be possible that the line just barely touches it and you only get one solution for a line and parabola. So just remember there's different ways they can intersect, and that's why you get different numbers of solutions. All right, here's another one. It's actually set up already for substitution. We have y equals, we'll just plug it in there. So now we will combine like terms and make this be standard form. So let's put the negative x squared first, followed by our 2x, and let's subtract our 1 over, so that's 3. Now we don't want that negative there in the front, so let's change all of our signs. And now that is factorable. Multiply to be negative 3, add to be negative 2, negative 3, positive 1. So we get x equals 3 and x equals negative 1. Same thing as before. Now we're going to take those two solutions and plug them in to our y equals equation. So we've got our equation is y equals 4 minus x squared, and we're plugging in x equals 3 and x equals negative 1. So now plug those in. We get y equals 4 minus 3 squared, that's 9. So y is negative 5. So our ordered pair is 3, comma, negative 5. We plug in negative 1. Negative 1 squared would be 1, so we got 4 minus 1, which is 3. So our ordered pair is negative 1, comma, 3. Two solutions, 2 points where they cross. Again, this was a line and a parabola. Makes sense that we get those two solutions. All right, this one's a little bit harder because they both have x squareds. It actually is going to work out just the same though. We have y equals, so it's ready for substitution. We just replace y with what it equals. So we have x squared squared, which means x to the 4th. And this becomes factorable. Let's write it in standard form. So it's still factors the same way that we've been doing. It's just our exponents are different. So this factors to be x squared and x squared. Multiply to be negative 1, add to be positive 1. That actually won't work, so this is not factorable. So let's actually use our calculator here. So since we have a polynomial equation, we can go into equation solver here. And it is a polynomial, so we'll go to F2. It's got a degree of 4. That's the largest exponent. Then you type in the coefficients. Remember that we got to skip over the x cubed as well as the linear x. So that's going to have coefficient of 1, and then a 0, and then a 1 for the x squared, a 0 for the linear term, and then a negative 1 for the constant. We can hit solve, and we get these two decimal answers. It's not They're not really great answers to go with, but it will work out. We'll get some results here. Now, the other thing you could do is you can do quadratic formula to solve this out as well. You just have to remember that when you do quadratic formula for higher degrees like this, you're not solving for x, you're actually solving for x squared. So quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. And we can plug in all these numbers here. So b is 1, 4 times a times c. So that's 4 times 1 times negative 1. Would be negative 4. All over 2a, and a is 1. So this is x squared. Would be negative 1 plus or minus a square root of 5 over 2. But then remember we have to do square root of all of that, and it's plus or minus. So those should be the same decimal numbers, but that's not really that useful to go with. If we type that in though, negative 1 plus, we'll just go plus the square root of 5. And then divided by 2. And then we need the square root of that answer. This should be one of those two decimals that we had there. Yeah, that looks like it. So we really just have to plug those numbers in. It's kind of messy here. The reason why it's like that is based off of what these two things are. With those decimals, y equals x squared is a parabola. X squared plus y squared equals 1 is a circle. This parabola hits the origin and the circle goes around the origin. So it's a circle and a parabola. And we've got those two solutions right there. You can also do this by graphing. So let's go to a graph. Y equals x squared, that's easy to graph. Our second graph would be the circle. Now in order to graph this, we have to make it be y equals. So we would subtract the x squared to get y squared by itself, and then plus or minus the square root, so that we have y equals. So we're just going to graph the top. Well, we can graph both parts. So positive square root of 1 minus x squared. We only need the top part because we know that that's where it's going to intersect, but I'll graph them both. So the second one would just be negative square root of 1 minus x squared. So this should look like a parabola and a circle, like I mentioned. Let's get a standard window. Kind of hard to see there, but it's almost exactly. We can zoom in a little bit, or we could just change our view window. We know it's only going out to the 1s because that's what the circle is. So I'll go a little bit further. I'll go 2s, negative 2 to positive 2. And it just doesn't look like a circle because this window is not square. There is actually, you can do zoom box and zoom square and all that sort of stuff if you wanted to make it look more like a circle. So going from there, really all that matters is that we have these points of intersection because that's what we're finding. We know one of them had that, they're both like 0.7, positive and negative 0.7 something. So to get the intersections, we just go G-solve intersection. We have to choose our two graphs, so the y equals x squared, and we know it's on the top the positive square root. So we've got one solution, and then if we just scroll, we get the other solution. They are the same number, 0.618. So we'll write those down just as decimal approximations. 0.786. It was plus or minus 0.786. And it's 0.618. So these were our two solutions. There's no better way of writing that than just the decimal, so that's okay. All right, so you can solve them by hand with substitution. You can solve them with the calculator, with graphing. This would also be able to be graphed. This is another circle. If you remember from geometry, this means the center is 2, 1. And then the radius is 1. So it's going to look kind of like that. That's not very much like a circle, but that's okay. And then y equals x plus 3. That's a line. Kind of goes up like that. So it's quite probable that these will not intersect at all. Just by looking at our sketch that we made. So we can do our substitution and find out here. Replace y with what it equals. So this is x minus 2 squared. And this is x plus 2 squared. Now, if you multiply these out, you get x squared minus 4x plus 4 and x squared plus 4x plus 4. So that's 2x squared, the x's cancel. And subtract the 8 over, you get negative 7. Now when we go to take a square root of a negative, we will get no solution. So that's where that comes about algebraically. And from our sketch, we can see that they also don't intersect. So no solutions there because the line misses the circle. Here's another one. We can do substitution. It's a little bit harder, but that's okay. You can have y equals just divide by x there, so it'll be 8 divided by x. And then we're substituting in place of the y, so that's going to be 8 over x squared. When you square a fraction, you square the top and the bottom. So that's 64 over x squared equals 20. And if you're going to solve this out, I would multiply by the denominator to clear it all out. So we get everything times x squared. It's going to cancel our denominator. So we get x to the 4th plus 64 equals 20x squared. And make that be standard form so we can solve. And let's see, is this factorable? 64 multiply by 64, add to be 20. Let's see, 8 and 8, 16. How about 16 times 4? That is 64, and 16, if they're both negative, that'll work. So that's x squared minus 16 and x squared minus 4. So as we solve this, square root of 16 is plus or minus 4, square root of 4, plus or minus 2. So we actually get 4 solutions here. Now when we look at what these are, we have a circle. This xy equals 8. This is kind of weird, but it's since it's this 8 over x, that's a little bit familiar with our parent function for rational functions. So when you have that and a circle, it's a bad circle, but you can see that this could intersect 4 times, and that's exactly what we have going on. That's why we have 4 different answers. Plus or minus 4, plus or minus 2. So yes, you need to plug all 4 of those in to either equation. I think this is going to require the least amount of work, 8 divided by x. And we have those 4 solutions. So when x equals 4, that means we have y equals 8 divided by 4, which is 2. So that's y equals 2. So our ordered pair, I don't know why I wrote that again, but our ordered pair would be 4, 2. Same idea with the negative 4, so we've got 8 divided by negative 4, that's negative 2, so our ordered pair is negative 4, negative 2. And then when we had x equals positive 2 and negative 2, we get y equals 8 divided by 2, which is 4, so that ordered pair, 2, 4. And then y equals 8 divided by negative 2 is negative 4. So negative 2, negative 4. So we have 4 ordered pairs, and that matched up with what we said about the graph. Should make some sense there. All right, so now we're going to look at a different way of solving. Everything we've done so far was substitution or graphing on the calculator. You can also do elimination when it matches up. So you want to see that all of one variable cancels out. So if there's an x squared and an x and all of that, we just want to make sure that all the x's cancel out or all the y's cancel out. And we can see that's happening here with our x squareds. These can cancel out pretty easily. You can multiply or just change the signs, whatever you need. If we just multiply this top equation by a negative, when we add these straight down, we'll combine like terms and cancel out our x squareds, which means there's only y's left in our equation. X squareds canceled. And we get equals 8. So now this is actually a pretty easy equation. We're used to solving when there's x's here in the equation. It's really no different when there's y's. We just have to remember that they're y, so that when we plug them back in, we just put them in the right order. So this is factorable. Multiply to be 8, add to be 2. That's 4 times 2. It would be 4 minus 2. So we get y equals negative 4 and y equals positive 2. So now we're going to take those, we can plug them into either of these equations. You just have to decide if you want to have to square the numbers or multiply by 2, whatever math you would rather do in those equations. So pick your equation. Let's do squared isn't too bad, so let's do that. Either way, you'll get the same results. So when y equals -4, that goes to x squared plus -4 squared is 16 equals 16. Subtract, you get 0 equals x squared, which means square root, and you get x equals 0. So our ordered pair, x is 0, y is -4. Same idea, but this time we're plugging in 2. So that's x squared plus 2 squared is 4. Subtract that 4 over, we get x squared equals 12. So x equals plus or minus, when you do the square root, square root of 12. That can be simplified a little bit because that's 4 times 3, so that simplifies to be 2 square root of 3. So when we got one solution here. When we plugged in 2, though, we got 2 different solutions. So that makes 2 ordered pairs. When y is 2, we get 2 different answers. We get positive 2 square root of 3, comma, y was 2. And we also have negative 2 square root of 3 when y was 2. So we got 3 solutions here. So let's draw a strange box around it because that's the way they lined up. 3 solutions. All right, same idea here. These are ready to go. They'll cancel out. X squared will cancel. We get y squared plus y equals -5 because that's pretty easy and straightforward. This is not factorable, so again, we're going to get some decimals. Let's go ahead and we can just type this into our calculator. We can solve this out. If we're going to use our calculator, we might as well use the graph because it'll give us the x and y coordinates all at once. So x squared plus y squared equals 4. Similar to the circle we solved before, get y squared by itself, and then plus or minus the square root. So the only thing that changes here is that 1 is going to change to a 4. So it's plus or minus 4 minus x squared. And then our other equation is y equals x squared minus 9 once we move that over. So again, we have a parabola and a circle. Ooh, and look at this. When we look at the graph here, they miss. The circle's inside the parabola, so that's actually pretty easy. Not even decimals, we just get no solution. I guess if we would have done quadratic formula here, we would have got our discriminant would have been negative, so there would have been no real solution. All right, so we'll take a look at a hard one here. It looks hard. It's really not, because if everything was lined up, you would see that the x squareds cancel out. They're ready to go already. That's your clue. And we also have negative 24x, positive 24, so those are going to cancel out too. And your x squareds are going to cancel out. And your positive 25, negative 25 is going to cancel out. So we put that all together. The only variable that remains is 11y squared. Negative 51 and negative 48 is negative 99. And then 0 and 0 when we combine those. So we get 11y squared equals 99. divide by 11, you get y squared equals 9, which means y equals plus or minus 3. We have two answers to plug in. This gets a little tough because now we have to plug in y into these big messy equations. We're plugging in positive 3 and negative 3. So choose where you want to plug it in. I personally would choose the top equation because there's only one place to plug it in. We don't have to plug it in to both locations of the y. We just have to plug it into the one location of the y because that's all there is. So for y equals positive 3, we get 6x squared minus 24x. 25 times 3 is 75. Combine like terms. And that's 24. So 6 goes in evenly to all of these numbers, so let's divide everything by 6. And now this is pretty easy to factor. Multiply to be 4, add to be negative 4, that's negative 2 and negative 2. So we get x equals 2 and then x equals 2 again. So it's only one ordered pair. X equals 2, y equals 3. X equals 2, y equals 3. So that was from y equals positive 3. Now we need to plug in y equals negative 3. And our equation, 6x squared minus 24x plus 25 times y, and y is negative 3, so that's negative 75. And then the rest of it was just minus 51 equals 0. So again, we're just combining like terms first. So that's 126. I think that's divisible by 6 also. So we can divide everything by 6. Yeah, we get 21. Divide by 6, we get 4. And divide by 6, we get 21. And this is factorable because 7 times 3 is 21. And negative 7 plus 3 would be negative 4. And it's negative 21 like it was supposed to be. So we get x equals 7 and x equals negative 3. So two different x's when y was negative 3. So 7 comma negative 3. And then the other one down there is negative 3 comma negative 3. All right, I've got a couple more examples on here, but I don't think you'll need them. They all follow this same thing. We just combine like terms, solve it out. They all really kind of match up the same, and this video is already getting pretty long. So go ahead and complete your worksheet that goes with this, 6.6 worksheet, and get it submitted. And as always, ask questions in our discussion, or like, subscribe, do all of that, whatever YouTube stuff that you want to do. And have a good one.